Today we want to look at this physics question under application of momentum. Alright, now it talked about the brakes of a car of mass this are applied and the speed is reduced from uniformly from this to this in this time. Find the braking force. That's the first question. Then the second question is, if the brakes are kept on, after what further time will the car come to a stop? Now this is a practical question because we know that when brakes of a car are applied, the car will definitely come to a stop. So we want to get the further time. Now the first thing you do is write out the information you know first, okay? The information given to you. Then whatever is not given, you put a question mark, okay? Now we have the mass m. M is given, okay? M is given as 500 kilogram. The initial speed 14. U is 14 meters per second. The final speed is 10 meters per second, and the time taken, all right, is 8 seconds. All right, now we know the time, we know this. To get the braking force, we have to remember the Newton's second law of motion. Okay, the second law of motion states that the force, applied force on a body, okay, on a moving body, is directly proportional to the rate of change in momentum. So force is directly proportional to the rate of change in momentum. That's change in momentum this way per time. That's the rate of change. And if we use a constant 1, then we have our formula as F equals to mv minus mu over the time taken. So we have a formula now, okay? And if you observe closely, this formula is what translates to F equals to mass times acceleration, because this part, if you bring m out, you have v minus u over t, which becomes acceleration, or the change or the increase in what? In velocity, okay, or speed as it were. Now we can write our formula as F equals mv minus mu all over t. So the m is 500, well, 500 times the v, which is the final, is 10, minus 500 again, times initial is 14, divided by the time, so our time is 8. We will simplify this further. This is 5,000. We have 5,000 there. Negative, oh, this is 14. If we multiply these two, we have a 0, 0, 5 times 14. This is 7,000 divided by 8, okay? We're going to get a negative 2,000 divided by 8. That's the force. So finally, force is equals to negative 250 newtons when we divide this, okay? So the reason the force is negative because it's a retarding force. It's a force that causes a deceleration or a reduction in speed or a reduction in velocity, okay? And as you can see, the velocity is actually reducing. From 14, it's reduced to 10, okay? And if we continue to maintain this force of negative 250, the final velocity will keep dropping until it gets to 0, at which point the car will stop. And that's what the B part of the question wants us to calculate, okay? Let's go back to the B part. It says if the brakes are kept on, after what further time will the car come to a stop? So we are going to use this result to solve the B part of the question. So if the force is maintained, a retarding force which is negative 250 Newton, we want the car to stop. So the final velocity now should be 0. That's what we want, meter per second. So what velocity will it be coming from? What will be the initial velocity? Now we have to go back to the question to get that. The initial velocity now will be this, no longer 14, okay? Because the car has gone past 14 to 10. So from 10 now it's moving to 0. So the initial we are going to use now is 10, all right? And the final is 0 to solve the B part. So our initial velocity now, u, okay, is going to be 10 meters per second. So the same formula, F equals mv minus mu all over t. We could factorize m out here, and when we do, we now have that our formula is m open bracket v minus u all divided by time. So what's our force? Is a negative, a retarding force. Negative 250 is equal to the mass of the car doesn't change, it's still 500. Open bracket, our final velocity here is 0 minus our initial velocity now is 10 divided by, we're looking for the time it will take for the car to stop, okay? So over time. Now we will need to simplify this further, okay? So if we cross multiply, we have a negative 250 t is equals to, this is 500 open bracket, the result here is a negative 10, so I have a negative 10. So negative 250 t is equal to negative 5,000. We'll multiply this. From here now, we can divide both sides by negative 250 to get time. So time is negative 5,000 divided by negative 250. Negative cancels negative, so the time now is going to be this. We cancel this, 500 divided by this, that will go 2 times here, so we'll have 20 seconds, okay, as our final answer. So that's the required time. All right, so I'll see you in my next video. Cheers.